Okay, ladies and gents, you watched a video over limiting reagents. And as I told you on Friday last week, that limiting reagents for some reason is a tough concept for students of the past to understand. Okay, so we're going to do a couple of examples today. We're going to run through another example tomorrow of it. But we'll start out with this one. If 40.0 grams of sodium bicarbonate combines with 6 grams of sulfuric acid, how many grams of sodium sulfate will be formed? Well, the first thing we have to do is we have to have a balanced chemical equation. So let's go through and figure out our equation. We know that we have sodium bicarbonate. Sodium is a +1. Bicarbonate is HCO3 polyatomic -1. Sulfuric acid, H2SO4. IC1 or 3, that's rule number 3 of your acid rule. So sulfate. It tells us one of the reactants, sodium sulfate. The other reactant then, if we switch, because this is a double replacement, is going to be an acid, and that's going to be sodium, check. It's going to be carbonic acid, H2CO3. Now I've got to balance this guy up. So if I look, probably where a big problem is going to be is with this H right here. So my H's are going to give me some trouble. Let's start with sodium, though, and balance that sodium up. My sulfate's good. My carbonate is good. I know my carbonate's not good. Now my carbonate's good. So the only thing that I do not have good right now is hydrogens, and those are good. I believe that's balanced. What do you believe? Okay? So I have a balanced chemical equation. Now, the big thing with limiting reagents, okay? The big thing with limiting reagents is they tell me that I have 40 grams of that, and I have 6 grams of that, right? What do you think the chances are that all 40 grams of the sodium bicarbonate are used up, and that all 6 grams of the sulfuric acid is used up? What do you think the chances, though, that they'll react exactly in those amounts? Okay, it's not very good. Something has to be used up. Okay? Something has to be used up. I believe in the video, didn't they have water in the little packets? Didn't I use that? Okay? So if I have 6 bottles of water and I only have 4 packets, what am I going to run out of first? The packets, right? I got 6 bottles of water. I only got 4 packets. So how many bottles of water am I going to have extra? 2, right? That's basically what's going on here. Something's going to run out first. We just have to determine what it's going to be. And you're going to see that these problems are long, because we got to do a lot of things to determine them. So the very first thing I need to do is I need to find out what my limiting reagent is and what I have in excess. What do I have extra of? I can pick either one. A lot of people, folks, look at this and say it's going to be 40 because it's bigger. That's not the case. Okay, that's not the case. It's not 40 because it's bigger. We have to do calculations. So what I'm going to do is I am going to do a mass-to-mass calculation. And I can pick either one. And what do I mean by that? I can start with sodium bicarbonate and go mass-to-mass to sulfuric acid, or vice versa. I can start with sulfuric acid and go mass-to-mass of sodium bicarbonate. It does not matter which way I do it. So I'm going to make my big, long conversion box. I've already done the calculations, so 84.00661 grams of sodium bicarbonate is the molar mass, and that is 1 mole of sodium bicarbonate. So now I get my grams to cancel. I've now converted that into moles of sodium bicarbonate. I look at my molar ratio. 2 mole of sodium bicarbonate is 1 mole of sulfuric acid. My moles of sodium bicarbonate cancel. Now I have to convert it back into the mass. Well, 98.078 48 grams I get my moles of H2SO4 to cancel. So now when I do my math, I've converted this into grams of H2SO4. And I come up with a value of 23.35 grams. Can we agree on that number? I didn't sig fig it yet. Because I want to make sure that I get my limiting reagent correct. So, here's the deal. What is this telling me? Well, this is telling me that, let's just look at this right here. If I have 40 grams of NaHCO3 to react with that 40 grams equally, I need 23.35 grams of H2SO4. So to get 100% Of those 40 grams to react, I need 23.35 grams. Do I have 23.35 grams? No, I do not. I only have how many? 6 grams. So what is going to limit this reaction? This is the big one, the tough one. Okay? What limits this reaction? What will I have left over? Okay? So you ask yourself, what do I not have enough of? Which is it? The acid, right? I only have 6 grams. I only have 6 grams of that, and I need 23.35. Now, I'm going to erase this one, folks, right here. I'm going to erase this part right here, and I'm going to show you, because I told you, I could pick either one. So now, I'm going to pick 6 grams, because that's what I have of sulfuric acid, right? Let's say I went with 6 grams of sulfuric acid. I'm going to do the same process, and it's going to be, folks, very similar. It's just going to be the numbers are going to be at different places. So I'm going to convert mass to mass from sulfuric acid to sodium bicarbonate. Now I've converted that to moles, my molar ratio. Now I've converted that into moles of sodium bicarbonate. So, as I'm doing this, I do my math. I come up with grams of okay, and I came up with a value of and I didn't round or I didn't sig fig this, okay? I came up with this value that if I have, and what this is telling me, let's go through and let me go through and do this again. It says, okay, this tells me that if I have 6.0 grams of H2SO4, I need 10.278 grams of NaHCO3. Now, if I look at it this way, do I have 10 grams, 10.278? I have way more, right? I have way more than that. Matter of fact, and you'll have to do this on WebAssign, folks. You'll have to do this because it'll say, well, how much left over will you have? Okay, well, I have 40, right? If I take away 10.27, what am I going to have? Excuse me. So that'd be 7 point. Is that right? 29.73? That's how much I would have left over of the sodium bicarbonate. So basically, what is my limiting reagent? Sulfuric acid. What is my excess reagent? Sodium bicarbonate. That's the toughest part to determine. Which is which? Okay, which is which? Now, we've done all this work already, right? Okay? We've done all this work and we still haven't answered the question, have we? What was the question? How many grams of sodium sulfate are formed, right? So, I've got to figure out how many grams of sodium sulfate are formed. Now, this is important, which one I start with. Okay? Which one do you think I should start with? Okay? Which should I use to, which number should I use, which value should I use of my mass to start my calculations? The limiting reagent. Because did I use all of the other one? No. I've got 29 left over. So I'm going to start with 6.0 grams of sulfuric acid. And I'm going to go mass to mass of sodium sulfate. I've already got my sulfuric acid number, 98.07848 grams. My grams cancel. I've got that into moles. I need to go back and look at my molar ratio. And it's a 1-to-1 ratio. So 1 mole of H2SO4. There's 1 mole of Na2SO4. So now I've converted that into moles of sodium sulfate. I need to go back to mass. 142.04214 grams of sodium sulfate is 1 mole of sodium sulfate. My moles cancel. So now I extend my page even more. Now I'm going to get my answer in grams of Na2SO4. I do my math. And I come up with a value of 8.6889. That's enough because I look way back. How many sig figs do I need? 2 because of 6.0, right? So if I round that to 2 sig figs, there is my final answer. So how much is involved to do this one calculation? Quite a bit. These are long problems. Now, I did a mass-to-mass that I didn't need to do because you don't have to do both. You don't have to do both of the starting reactants. You only have to do one of them to determine what your limiting reagent is. Okay, you only have to do one of them. Now, here is our second one. Go ahead and write this down in your notes. If 35.0 grams of sodium metal is reacted with 35.0 grams of water, how many liters of hydrogen gas will be given off if this reaction is at STP? Okay. Once again, a lot of stuff going on here. Very first thing we need to do is we need to find a balanced chemical equation. So I can see that I have sodium reacting with water. If I have sodium reacting with water, this tells me this is going to be a single replacement reaction. So, sodium metal reacting with water is going to give me, that's not water, is going to give me sodium hydroxide and hydrogen gas. Now you're probably going to need to use your help sheet from reaction predictions to do some of these if you need your balanced equation yet. Okay? This is not balanced. I can see probably my biggest problem is that I have an odd number of hydrogens here, and I cannot have an odd number of hydrogens. So I'm going to start off putting a 2 there. Excuse me. If I put a 2 there, that gives me 4 hydrogens. So I put a 2 there, that balances up my hydrogens, that balances up my oxygens. A 2 there balances up my equation. So I have a balanced chemical equation. Now, like I said before, does it matter which one of my reactants I start with? No. I'm just going to, since it's listed first right here, I'm going to start with sodium. 35.0 grams of sodium. And I'm going to go mass to mass of what? I'm going to go mass to mass right now. Okay? To what, though? Mass of sodium to mass of water, my other reactant. Sodium is 22.98977. My grams cancel. I've converted that to moles of sodium. My molar ratio, 2 mole of water is 2 mole of sodium, right? My molar ratio, 2 to 2. Finally, I go back to mass of water, 18.1, excuse me, 18.01528 grams of water is 1 mole of water. My moles of water should cancel, and they do. So, as I'm doing my math, I'm going to come up with a mass of water, and When I do my math, I come up with a value of 27.4 grams of water. So, if I have 35 grams of sodium, I need 27.4 grams of water. Do I have 27.4 grams of water? Yeah, I've got 35 grams of water, don't I? So I would have roughly, what, 7.6 left over of water? So what is my limiting reagent? What is my limiting reagent here? Sodium. I don't have enough of it, okay? I have excess, well, I have enough sodium, but I have excess water. So, now once again, I've figured out my limiting reagent, but I haven't solved my problem yet because I want to find liters of hydrogen gas, right? I want to find liters of hydrogen gas. So I'm going to start with my sodium. This time, I'm going to go mass to volume because I want liters of hydrogen gas. I still have my number for sodium. It hasn't changed. So now I've converted that to moles of sodium. My molar ratio is going to change because I only have 1 mole of hydrogen gas. I have 2 mole of sodium. So now I've converted this to moles of hydrogen gas. Here's the easy part. I know that 1 mole of hydrogen gas is 22.4 liters because I am at STP, right? It was stated, yes, it was stated that we're at standard temperature and pressure. So, I do my math. And I come up with a value of, just checking, 35.0 tells me that I have 3 sig figs. And I have 17.1 liters of hydrogen gas. (17.1 liters of hydrogen gas). So, like I said, folks, these are not easy. These are a little lengthy. Okay? But nonetheless, you have everything. There's really there's nothing new that we're doing because all the calculations are just the same thing. The new thing is figuring out, okay, what is actually limiting this particular reaction?